This portion of daylighting class will address the basics of computational simulation procedure, which is to predict the daylighting quality of the space that you are designing in the early phase. I wish to remind you that there are two different aspects of how to measure light levels. There are illuminance and luminance. Illuminance measure the amount of light hitting the particular surface area. On the other hand, the luminance or brightness is the amount of light hitting finally perceived on our eyes, or how much is hitting the light meter. These two images show the comparison between the array of the value of light depending on whether the luminance or illuminance value is being measured. General space design is mostly done using the illuminance value. At the same time, advanced daylighting also uses the luminance value to control the excessive glare. In the past, the metric of daylight factor was widely used. The daylight factor is the ratio of illumination between indoor to the outdoor. A room with a daylight factor of 5% is considered to be well lit. A daylight factor of 2% is also widely used as a threshold for offices or classroom with a supplementary lighting to be installed. However, the most significant limitation for using this concept of daylight factor is that this applies only to the overcast condition when there are a zero direct solar radiation. When you think about the fact that this definition was invented in London, it might make sense. This measurement only represents the actual reality for cloudy conditions. Since the daylight factor measures the lux levels ratio between inside and outside, the threshold will vary based on the latitude you are in, since the design sky illuminance level will also vary between where you are. But in general, the lower threshold is considered to be 2%, and when it is above 5%, the room is considered to be designed with excellent daylighting performance. Due to many previously stated limitations, the concept of daylight factor is being outdated. Then, what would be a better way of predicting the daylighting quality of the space? We want to first account for the exact external daylighting condition, which includes the direct solar as well as the diffuse lighting of the sky. And we also want to incorporate the overall time of the year, not just the point in time, which adds up to the climate data that is constantly changing throughout the year. There are substantial amount of weather data available for over 21,000 locations worldwide, which we already looked at. We will learn matrix to gauge how well a space is lit by the daylight based on the sun's entire movement based on these actual monitored data. Due to the short time frame that is allotted to cover the topic of daylighting, as a class, we will be using a dynamic daylighting app provided at the andrewmarsh.com's website. Although this tool is pretty much basic and simplified, this daylighting simulation tool has undergone an extensive verification process to generate a very close result to some of the more advanced software such as Diva or Daisen. We will use this tool to study the relationship between daylight's spatial distribution in a room and its size, aperture configuration, shading devices, external obstructions, and the geometry of the space. Inside this application, the first thing is to prepare the room geometry. Once you do the modeling using the software's tool, Make sure that the orientation is correct. Then the next step is to prepare grid points for the analysis. These grid points can be generated generally based on the 2 feet on center. Since we are measuring the desk's work plane, 3 feet above the finished floor is the typical height for the array. Then we set the general reflectance of the interior model elements. Based on the setting, each surface will reflect light around in a different manner, affecting the overall distribution of the incoming light. Usually every ceiling material is designed with white or reflective material to bounce rays deep into the interior space. Therefore, the ceiling is generally set to be 70% reflectance, and the floors are typically 20%, and wall materials are around 40 to 50%. The software's general setting is selected as a default based on these typical assumptions, but still you can control over these values based on your design choice. You have an option to make the point-in-time analysis, through which you see a lighting scenario at a particular point in time that you set. This can be used as a variable method based on what or when you want to look at your space. But solely making this point-in-time simulation is not the sufficient way of understanding the space's daylighting, since these are only partial and not the holistic way of looking at the space. Finally, we want to analyze the design based on the entire annual climate date, which comprises 8760 hours per year. The climate-based analysis takes the TMY weather data points, which contains the information of this 8760 hours measurement. It runs through the geometry of the elements comprising the model that you created, and as a result, it creates a nice holistic chart with a different simulated result values for each different point separately, represented with the help of the color legend. This process of simulation uses several simulation matrices, which we will talk about it next.